In the next few minutes, you'll learn how to teach GPT to write and execute SQL queries with any database. This allows you to harness real business data, uncover insights like identifying the top-selling albums and analyzing sales trends over time. We are building this completely from scratch, and it's designed for easy following. We'll use a real-world database that you can download from GitHub. Plus, if you're interested, you can get access to the code and use it as a foundation for your projects. And there are just 3 simple steps to connect any database in the world to GPT via function calling. Let's begin with the first step. Our objective for the first step is to ensure we can connect to any database, and our code makes the structure accessible to GPT so that it can write SQL queries against the tables. The question becomes how we can inform GPT about the names of the tables and columns. Let's see. So first of all, as always, we want to create a virtual environment to keep the dependencies separate. We then activate this, and we create a file named app.py. First, we import SQLite 3 and establish a connection using the connect method. And for this, we want to use the Chinook database. I have already downloaded this beforehand. We copy the database file from the downloads folder into a new data directory, enabling us to access it from our script. Next, we create a method that returns all the table names of the database. We call this getTableNames. And for this, we perform an SQL query that outputs the names of all tables in the database. In SQLite, information about the available tables is stored in the SQLite master table. Then we iterate over the result and add the query result to the list table names. Our aim is to compile a neat list of all tables that can be processed by GPT. We return the names. We can also output these and see that when we execute the script, we have tables like albums, artists, customers, employees, genres, etc. However, we still need more data than just the table names. I have already prepared code that also returns the column names for each table and takes a table name as a parameter. And then we actually have another method that turns this collected information into a dictionary. Let's display the output of the getDatabaseInfo method to make things a bit clearer. And we see that we have the name plus the individual columns of the table neatly listed one after the other. If you compare this with the data model, you'll notice that it perfectly summarizes how the database is structured. Since AI or GPT can do less with JSON, we now need to convert this into a string. And for this, we can make very good use of the join method. And what we do is output the table name and concatenate all the table names with a new line. We will now take a look at what exactly this means. And we see that we now have all tables as a string listed one below the other with their respective names. And now, in the line below, we actually add an overview of all columns in the respective tables. For this, we use the join method again. And what we do is join the column names together using a comma and a space as separators. The result looks like this. We now have a neat list with the table name and the column names, which we can then pass on to the function declarations in the next step. First step accomplished, now it's time for step 2, writing SQL queries with GPT. Okay, now we actually come to the definition of the function and its declaration. I'll copy and paste the pre-written function declaration to make this video more streamlined. We see that our database schema is also being used here. And we have a description of the function with its name and the respective parameters it takes, so that GPT knows that this function exists and how to use it. Now we build the actual implementation. The method is named askDatabase, and it accepts a parameter named query. This method establishes a database connection and then executes the specified query. And we test this once. We test it with a query that retrieves all albums from the database. And when we execute it, we wonderfully see that we get back all entries for this query. Good, next we do the integration of OpenAI. For this we install OpenAI with pip install OpenAI and import it at the top of the file. Furthermore, we also import OS, so we can access environment variables and read the OpenAI key. Then we create a new client that can read the API key from the environment variable. Don't forget to set the environment variable before running the script. And we also create our chat completion. Here we call chat completions, create on the client, passing a messages array, and this time we have not only the user role, but also the system role. And we tell it to answer user questions with generated SQL statements. And in the role of the user, we then actually make the actual prompt. In this case, we want to know what the top 5 artists are based on the number of tracks in the database. As a model, we use GPT 3.5 Turbo to get quick results. Then we must still assign the tool, so that ChatGPT knows which tools are available, and based on our tool's definition above, knows how to use this function. We can now take a look at the return value from GPT. For this, we have to access the first message from the result. And we see, in response to our question, an answer was actually generated that suggests the use of the R's database method with an argument, and this argument is actually the database query that could probably answer our user's question. What we now want is for this query to be actually executed directly against the database. Congratulations! We have reached our final step, executing GPT's queries. Therefore, we need to utilize the method name and the arguments from GPT's answers. We check if the name of the method to be called is actually R's databases. And if it is, we read our query from tool call function argument. And of course, we also have to convert its content into JSON so that it can be processed correctly by the method. We need to import JSON, and now we can get the result from the database by calling the R's database method with the JSON we just read out. We output the result, and we see that Iron Maiden, Led Zeppelin, Metallica, U2 and Lost are indeed the top 5 artists. Let's try out a second request. For example, what's the name of the album with the most tracks? We run the script again, and it returns greatest hits as the result. It seems that everything is working seamlessly. Now we have everything in place. If you're interested in adding a beautiful UI like the one shown in the teaser, please check out the links in the video description for access to the code. And don't forget to like and subscribe to stay updated on the next video in this series.